Hi, welcome. Let's take some questions on break-even analysis. Then I'll guide you on how to solve them. Question 1. Antiaraba sells biscuits in a shop around the corner. If a monthly fees cost is 1,800 cedis and a variable cost per unit is 6 cedis 75 pesos, determine the number of biscuits Antiaraba must sell to break even if a biscuit sells at 9 cedis 25 pesos. So to solve this, let's record the formula for break-even point in units, and that is F divided by P minus V, isn't it? Now, when you go back to the question says the fees cost is 1,800 cedis and the variable cost per unit is 6 cedis 75 pesos. And when you go further, the question says the biscuit sells at, okay, so this is the selling price per unit. This is the price per unit, 9 cedis 25 pesos. Okay, so we are going to substitute them in the formula. So when we do the substitution, we will have 1,800 cedis divided by the price, which is 9.25, minus the variable cost per unit, which is 6.75 at the denominator. Okay, 9.25 minus 6.75, you will get 2.5. Okay, so you have 1,800 divided by 2.5. So put this on your calculator. 1,800 divided by 2.5. That should give you 720. So Antiaraba must sell 720 biscuits to break even. So that is the answer to this. Okay. Question 2. Determine the break even volume if fees cost is 10,000 cedis, material is 0.75 cedis per unit, direct labor is 1.50 cedis per unit, selling price is 4 cedis per unit. So we want to determine the break-even. Okay, so to solve this, first let's record the formula for the break-even point in units, and that is F divided by P minus V, isn't it? But when you look at this question, we have the fees cost, which is F, as 10,000, isn't it? Now we have the P, which is the selling price, as 4 cedis per unit. Now, what is the variable cost? When you look at the question, you see that variable cost isn't given. So that means you need to find the variable cost yourself. Okay. Remember that the examples of variable cost are labor and material. Okay. So to get variable cost, you can simply add labor and material together to get a variable cost. So the labor cost per unit plus the material cost per unit should give you the variable cost. Okay, so that will be 2.25. So now we know the variable cost. We can now substitute them into the formula. So when we substitute, we have the 10,000, which is the fees cost, divided by the price per unit, which is 4, minus the variable cost that we've gotten here, 2.25. So 4 minus 2.25 should give you 1.75, isn't it? So that will give you 10,000 divided by 1.75. So take your calculator and enter 10,000 divided by 1.75. You will get 5,714 units. Okay, so this is the answer to this also. Question 3. Determine the value of sales at break-even if fees cost is 10,000, material is 0.75 per unit, direct labor is 1.5 per unit, and selling price is 4 per unit. This question is the same as the previous question we solved, but this time around we want to solve it in monetary terms. Okay, so to solve this, let's record the formula for break-even point in money. So break-even point in CD should be equal to fees cost divided by 1 minus V over P. Okay, now when you look at the question, we have the F to be 10,000. We have the P, which is the selling price, to be 4 cedis, but we do not know the variable cost. So to get a variable cost, since labor and material are variable cost, then we need to add them together so that we can get the variable cost. So variable cost is equal to 1.5 plus 0.75, and that will give you 2.25 cedis. So that's the variable cost. So we can now substitute them in the formula. So when we substitute, we have 10,000 divided by 1 minus Now the formula says V over P, so we'll take what we get for V, which is 2.25, over P, which is 4. So when we simplify 2.25 divided by 4, we'll get 0.5625, okay, and 1 minus 0.5625 will give you 0.4375. So enter 10,000 divided by 0.4375 on your calculator. That will give you 22,857.14 cedis. Okay. Now if it is MCQs, when you write down this first step, you can put this entire first step on your calculator to get the answer straight. Okay, then make sure you do that properly. Question 4. Calculate break-even point in units and in monetary terms. Given that unit price is $5, labor cost is $1.5 per unit, material cost is $1.5 per unit, utility cost for each unit produced is $0.5, and fees cost is $3,000. So the question wants us to solve two things: break-even point in units and in monetary terms. So to solve these, first let's find a break-even point in units, and the formula is F divided by P minus V. When we go back to the question gives us F, which is the fees cost, to be $3,000, and the price per unit is $5. But the question didn't give us the variable cost, so we need to find the variable cost ourselves. Now remember that examples of variable costs are labor cost, material cost, and utility costs. Okay, so this means that we need to add labor, material, and utility to get the variable cost. So let's do that. So variable cost will be equal to 1.5 plus 1.5 plus 0.5, and that will be $3.5. Okay, so let's substitute them in the formula now. So when we do the substitution, we get 3,000 divided by 5 minus 3.5. Remember that the P is 5, V is now 3.5, and F is 3,000. So 5 minus 3.5 will give you 1.5, isn't it? So now you have 3,000 divided by 1.5. Okay, so enter the 3,000 divided by 1.5 on your calculator, and that will give you 2,000 units. Okay, the reason the final answer is units and not dollars is that the dollar cancels the dollar. The currency symbol cancels the currency symbol, so you don't have any currency symbol anymore, so it's units. Okay, then let's find a break-even point in monetary terms. So to solve that one too, let's record the formula for break-even points in monetary terms, and that is F divided by 1 minus V over P. Now after recalling the formula, and remember that V is equal to direct labor plus material plus utility, and that will give us 3.5. Okay, so when we do the substitution, we have 3,000 divided by 1 minus 3.5 over 5. Okay, so take your calculator and find 3.5 divided by 5. That will give you 0.7. So you have 1 minus 0.7 at the denominator now, and 1 minus 0.7 will give you 0.3. So we will now have 3,000 divided by 0.3. So take your calculator and enter 3,000 divided by 0.3, and that should give you $10,000 in monetary terms. You can decide to enter the whole of this on your calculator. You'll get the answer straight without necessarily writing everything step by step. Also, since in the first question we know the break-even point in units, then you can also use this formula to find a break-even point in dollars, and that is break-even point in monetary terms is equal to break-even point in units times the price. Now remember, we got break-even point in units as 2,000, isn't it? And when you look at this question, the price is $5, isn't it? So let's substitute that in this formula. So we have 2,000 units times $5 per unit. Okay, so units cancels units. Okay, so 2,000 times $5 will give you $10,000. So you see that we get the same answer. So if you're able to get a break-even point in units, you just multiply by the price to get a break-even point in monetary terms. Question 5. The fixed cost is 3,500 cedis per month. We want to find a break-even point in monetary terms. So when you look at the table, you see that we have different products at different prices, at different costs, and at different annual forecasted sales units. So to solve this, you can redraw this table. Now when you draw it and you have everything in it, okay, then you create a new column for V over P, okay, you create a new column for 1 minus V over P, and then you create a new column for annual forecasted sales in monetary terms. You see here we have annual forecasted sales in units, so you should create it for monetary terms as well. Then you create a column for percentage of sales, and then you create a column for weighted contribution as well. So to do this cost here is the variable cost, is the V. So to solve this, we are going to take each V divided by the price, okay. So when you take 1.25 divided by 2.95, so that will give you 0.42 in 2 decimal places, okay. Then take 0.3 divided by 0.8, and that will give you 0.38 in 2 decimal places. And the next one should be 0.47 divided by 1.55, and that will give you 0.30 in 2 decimal places as well. And then 0.25 divided by 0.75, and that will give you 0.33 in 2 decimal places. Then 1 divided by 2.85, and that will give you 0.35 in 2 decimal places. So after getting the V over P, then you find 1 minus V over P. So together you are going to be taking 1 minus each of the values here, okay. So 1 minus 0.42 will give you 0.58, okay. 1 minus 0.38 will give you 0.62, okay. And 1 minus 0.30 will give you 0.70. And 1 minus 0.33 should give you 0.67, okay. And 1 minus 0.35 will give you 0.65. And to get the annual forecasted sales in monetary terms, you take the annual forecasted sales in units and multiply it by the unit price, okay. So 7,000 times 2.95 will give you 20,650. Then the next one should be 7,000 times 0.8, and that will give you 5,600. And the next one, 5,000 times 1.55 will give you 7,750. The next one, 5,000 times 0.75 will give you 3,750. And the last one, 3,000 times 2.85 will give you 8,550. Okay. So after getting the annual forecasted sales in cedis, then you add everything together, and that will give you 46,300. After getting the total, which is the 46,300, then you go to the next column, which is the percentage of sales. Now to get a percentage of sales, you are going to be taking each annual forecasted sales in monetary terms divided by the grand total. So for the first one, you take 20,650 divided by 46,300, and that will give you 0.446 in 3 decimal places, okay. And then 5,600 divided by 46,300, that will give you 0.121. 7,750 divided by 46,300 will give you 0.167 in 3 decimal places. And then 3,750 divided by 46,300 should give you 0.081 in 3 decimal places. 8,550 divided by 46,300 is 0.185 in 3 decimal places. After getting the percentage of sales, when you add all of them together, you must get a 1, provided you do your approximation properly. So we are going to find a weighted contribution. Now to get a weighted contribution, we are going to multiply the percentage of sales by the 1 minus V over P. Okay, so 0.58 times 0.446 will give you 0.259. Okay, then 0.121 times 0.62 will give you 0.075. Then the next one, 0.167 times 0.7 should give you 0.117. The next one, 0.67 times 0.081 will give you 0.054. And the last one, 0.65 times 0.185 will give you 0.120. So these are the weighted contributions. So when you add the weighted contribution together, you get 0.625. Okay. Now, after doing that, then let's recall the formula for the multi-product break-even point. The question says, fixed cost is 3,500 per month. And in the formula, we should use the year. There are 12 months in a year, isn't it? So the fixed cost for the year should be 3,500 times 12 months. Okay. So the fixed cost you are going to use in this formula, the F here, should be 3,500 times 12. Okay. And then this 0.625 we've gotten here is for the whole of the denominator here. We've solved everything in tabular form. That's why. Okay. So we are going to substitute that into the formula. So let's do the substitution. Now F is 3,500 times 12, isn't it? Divided by the whole of the down here. The whole of the denominator here is what we've gotten as 0.625. Okay. So we substitute it there. So 3,500, this is a mistake. Cancel one of these zeros. So 3,500 times 12 will give you 42,000. And when you take 42,000 divided by 0.625, you will get 67,200 cedis. So this is the break-even point in monetary terms for these multi-products. Okay. Question 6. Now this is the annual fixed cost, 34,000. So calculate the multi-product break-even point. So to do that, we can redraw the table. Then you create a new column for V over P, another column for 1 minus V over P, and annual forecasted sales, percentage of sales, and weighted contribution. Okay, so you have to keep the format. Then you find a V over P by taking the costs here divided by the price. So 2.25 divided by 3.95, that will give you 0.57 in 2 decimal places. Okay. So you do that for the rest also. So when you do that for each of them, these are the values you get. Okay. Then you go to the next one. The next one is 1 minus V over P. So 1 minus 0.57 will give you 0.43. 1 minus 0.44 is 0.56. 1 minus 0.44 is 0.56. 1 minus 0.60 is 0.40. And 1 minus 0.625 is 0.375. Okay. Then we also find the annual forecasted sales in monetary terms. Okay. And remember, to get the annual forecasted sales in monetary terms, it is the annual forecasted sales in units times the price. Okay. So 3.95 times 4,500 will give you 17,775. So you do that for the rest also. 6,000 times 0.5 will give you 3,000. And 2,000 times 4.8 should give you 9,600. And after doing that also, you find a percentage of sales. Okay. To get a percentage of sales, first you need to find the total of this. Okay. And the total of this is 36,450. So 17,775 divided by 36,450 will give you 0.488 in 3 decimal places. Okay. Then 2,700 divided by 36,450 will give you 0.074 in 3 decimal places also. So you do that throughout. Okay. And the last one is 9,600 divided by 36,450. And that is 0.263. Then after that we find a weighted contribution. So the weighted contribution should be the percentage of sales, okay, times the 1 minus V over P. And remember, when you add all these, you must get a 1. Okay. Now 0.43 times 0.488 will give you 0.210 in 3 decimal places. And then the next one, 0.56 times 0.074 will give you 0.041 in 3 decimal places. And then 0.56 times 0.093 will also give you 0.052. Then the next one, 0.4 times 0.082 is 0.033. And then the last one, 0.375 times 0.263 is 0.099. Okay, so when you add all these together, you get 0.435. Okay, so to find a break-even point in monetary terms, let's recall the formula. So the formula is fixed cost divided by summation 1 minus VI over PI, okay, multiplying the weight. Now, the 0.435 we've gotten here is for the entire denominator here, okay. So everything has been solved in the table. And then the fixed cost is given annually, which is 34,000. So we are just going to substitute that in the formula. So when we substitute, we have 34,000 divided by 0.435. So put this on your calculator, you will get 78,160.92 cedis as a break-even point in monetary terms. Okay. Question 7. Using the following data, calculate the break-even point, contribution per unit, and margin of safety in units. We've been given a selling price as 50 cedis, variable cost as 40 cedis, fixed cost as 70,000 cedis, and budgeted sales as 7,500 units. So to solve this, first we want to find a break-even. Recall that the formula for break-even point in unit is F divided by P minus V. Okay. So since we have F, we have P and V in the question, we only substitute in the formula. So let's do the substitution. So that will give us 70,000 divided by 50 minus 40. And 50 minus 40 will give you what? 10. And 70,000 divided by 10 should give you what? 7,000 units. So the break-even point in units is 7,000 units. Okay. Then the question is also asking for contribution per unit. So to find contribution per unit, so the formula for contribution per unit is price per unit minus variable cost per unit. Okay. So that will be 50 minus 40. Okay. And that will give us 10 cedis. So the contribution per unit is 10 cedis. Then the last question says we should find a margin of safety in units. The formula for margin of safety in units is budgeted sales in units minus break-even point in units. Okay. But the question gave us the budgeted sales in units. And we've also found the break-even point in units ourselves to be 7,000 units. So to get a margin of safety, we only take 7,500 minus 7,000. And that will give us 500 units. So the margin of safety is 500 units. Okay. In case you want to determine the margin of safety in monetary terms, then it should be the margin of safety in units times the price. Okay. So when we take the margin of safety in units, which is 500, and multiply it by 50, that will give us 25,000 cedis. So this 25,000 cedis is the margin of safety in monetary terms. Question 8. Using the following data, calculate the level of sales required to generate a profit of 10,000 cedis. Selling price equals 35 cedis, variable cost is 20 cedis, and fixed cost is 50,000 cedis. So to solve this, we are going to use the break-even point formula. But here, we are going to add a target profit to the fixed cost. So we write the formula as level of sales required to generate profit of 10,000 should be equal to the fixed cost plus target profit divided by P minus V. You see that this looks like the formula for break-even point in units. That is F divided by P minus V. But in this, you add a target profit. Okay. So since we know the TP to be 10,000, the P is 35, the variable cost is 20, and the fixed cost is 50,000. We only substitute them in the formula. So when we do the substitution, we get 50,000 plus 10,000 divided by 35 minus 20. So 50,000 plus 10,000 is 60,000, isn't it? And 35 minus 20 is 15. So we have 60,000 divided by 15. Okay. And that will give us 4,000 units. So this is the level of sales required to generate a profit of 10,000 cedis. Question 9. Using the following data, calculate the level of sales required to generate a profit of 7,000. So we have the P, the V, and the F. So to solve this, The level of sales required to generate profit of 7,000 is equal to F plus TP divided by P minus V. Okay, so all we'll do here is to do the substitution. So our F is 23,000, the TP is 7,000, the P is 6.5, and then the V is 3.5. That's the variable cost. So when we substitute, we have 23,000 plus 7,000, all divided by 6.5 minus 3.5. So 23,000 plus 7,000 will give you 30,000, isn't it? And 6.5 minus 3.5 is what? 3, right? So we have 30,000 cedis divided by 3 cedis. Okay, so cedis cancel cedi. So 30,000 divided by 3 will give us what? 10,000 units. Okay, so the level of sale required to generate profit of 7,000 cedis is 10,000 units. So in the next video, I'll give more questions and show you how to solve them. Thank you.